Hi, good day. So for today, we are going to talk about the functional groups. Functional groups are other elements existing in organic compounds aside from carbon and hydrogen. Primarily, functional groups are divided into two, namely carbonyl functional groups and non-carbonyl functional groups. For today, we are just going to focus on non-carbonyl functional groups. Specifically, we are just going to give name to these 7 major non-carbonyl functional groups. But before giving name to these 7 major non-carbonyl functional groups, there are actually two things that we need to do first. Number 1, every time that we encounter organic compounds with functional group, we should count first all the carbon atoms that organic compound has. Okay. And number 2, we should also determine the carbon number 1 in that organic compound. Now take note that the terminal side, which is nearest to the functional group, will be the carbon number 1. For example, here, we have here an organic compound with hypothetical functional group. Let's say, for example, our A here is our functional group. Okay. Now we have here two terminal sides, this one and this one. This is not our terminal side here because this terminal side here is not made of carbon. It is rather made of a functional group of other elements. So therefore, our terminal side here will be this one and the other terminal side is this one. Okay. Now between these two terminal sides, which one is nearest to the functional group? Obviously, this terminal side is nearest to the functional group. That's why this is our carbon number 1, number 2, number 3, and number 4, and so on and so forth. Now, another thing that we should be reminded of are the names of alkanes. Remember that the names of alkanes are based on the number of carbon atoms that they have. For example, if an alkane has 1 carbon atom, then its name is methane. If it's 2, that's ethane. If it's 3, that's propane. If it's 4, that's butane, and so on and so forth. Now, these alkanes will serve as our parent chain in the functional groups that we are going to discuss later. Now, what are these 7 major non-carbonyl functional groups? For the first non-carbonyl functional group, let's have here the alcohol. Alcohol might be the most familiar non-carbonyl functional group to you. Primarily, alcohols are used as disinfectants or sanitizers. They are very important ingredients in cosmetic products. Now, the functional group of alcohol is OH, and its name follows the format alkane minus E plus ol. Again, that's alkane minus E. We're just going to eliminate the last E in the alkane name, our parent chain, plus ol. Let's give here an example. Let's have here this one. Obviously, this molecule is an alcohol because of the existence of OH. So therefore, this one is an alcohol. Now, our terminal sides here are this carbon atom and this carbon atom. These corners are our terminal sides. Now, between these two, which one is nearest to the OH or to our functional group? Obviously, that's this side. Therefore, this will be our carbon number 1, number 2, number 3, and number 4. Okay, obviously we have here 4 carbons, so its parent chain is 4 carbon. Its parent chain is butane, so we are just going to write butane. Minus E, we are just going to eliminate the E in butane, plus ol. So the name of this alcohol is 1-butanol. Another one is this alcohol. Now for this alcohol, we have here 1, 2, 3, 4, 5, 6 carbon atoms. This one is not carbon atom, it's OH. So it's not carbon atom. 1, 2, 3, 4, 5, 6. And our OH here, or the alcohol group, is actually located at the third carbon. Now here, our carbon number 1 is this part, or this terminal side, and our carbon number 6 is this terminal side, okay? Because this OH is nearest to this side than this side. And therefore, the name of this compound is hexane minus E plus ol. So that's 3-hexanol. 3 here corresponds to the carbon number where your OH or alcohol group is attached. In this case, the OH or the alcohol group is attached to carbon number 3. For the second one, let's have here the amine. Amine is one of the chemicals responsible for the stinky smell of rotten meat or dead animals. Primarily, amines are basic or alkaline, unlike the alcohols which are acidic. The functional group for amine is NH2, and its name follows the format alkane minus E plus the suffix amine. Let's give here an example. For example, in this compound, we have here 1, 2, 3, 4, 4 carbon. This one is not carbon atom because it's NH2, it's an amine group. Okay, our carbon number 1 here will be this one because this side or this terminal side is the one nearest to our amine group. And we have here carbon number 4 here. So we have here 4 carbons, therefore, carbon atoms, therefore, our parent chain here is butane minus E. We are just going to eliminate the last E in butane name plus amine. And therefore, the name of this compound is 1-butanamine. 1 because our NH2 here, our amine group here, is located at carbon number 1. Okay, for the next example, we have here 1, 2, 3, 4, 5. 5 carbon atoms. So therefore, our parent here or our parent chain here is pentane. And then we are going to eliminate the last E here. So pentane minus E plus the suffix amine. Okay, our amine group is here. Okay, and therefore, the name of this compound is 2-pentanamine. Why 2? Because our NH2 here is attached at carbon number 2. This is our carbon number 2 and this is our carbon number 1. This is not our carbon number 1 because this terminal side is actually the farthest side from our NH2. This side is actually the nearest side, terminal side to our NH2 or amine group. So therefore, its name is 2-pentanamine. For our third non-carbonyl functional group, we have here the thiol or mercaptans. One of the distinguishing characteristics of thiol or mercaptans is that they also have stinky smell, just like the amines. In fact, thiol or mercaptan is one of the chemicals responsible for the smell of onion. The functional group of thiol or mercaptans is SH. S is sulfur, and its name follows the format alkane, the parent alkane, plus thiol. Okay, so for example, for the first one, we have here 1, 2, 3, 4, 4 carbon, and we have here the thiol or mercaptan group. Now this one again is not carbon because it's attached to thiol or mercaptan group, so it's not carbon. Therefore, our carbon number 1 here is this one, 1, 2, 3, 4. Our carbon number 1 here is this because this terminal side is the one nearest to our thiol or functional group. Therefore, the name of this compound is 1-butane thiol. The alkane here is consists of 4 carbons, so that's butane. Then we also have here the SH or the thiol group, so butane thiol. Now our 1 here represents the carbon number where your thiol is attached. So our thiol group here is attached to carbon number 1. Therefore, its name is butane thiol. For the second example, we have here 1, 2, 3, 4, 5, 6, 7. 7 carbon atoms. Now this one is not carbon atom again. It's attached to SH, so it's not carbon atom. We have here 7. So our alkane name here is heptane. Then we have here the thiol group. Okay, so thiol. And where is our thiol located? Our thiol group here is located at carbon number 3. In this case, our carbon number 1 is this part, not this terminal side, because this terminal side is nearest to our thiol group, not this side. And therefore, this will be our carbon number 1, number 2, and number 3. Our thiol group is located at carbon number 3, therefore, its name is 3-heptane thiol. Next one is nitrile. Nitriles are primarily used in the production of chemical explosives like dynamite. The functional group of nitrile is C-triple-bond-N, and its name follows the format alkane plus nitrile. For example, we have here 1-butane nitrile, and our carbon number 1 is located here, not here, because this terminal side is actually the farthest side from our nitrile group. Okay, we have here 4 carbon atoms. This is the first carbon atom, triple bonded to nitrogen. Then this is the second carbon atom, third and fourth. Therefore, its name is 1-butane nitrile. 1, because our nitrile group is located at carbon number 1. For the next example, we have here 1-pentane nitrile. In this case, our carbon number 1 is here because this terminal side is actually the farthest from our nitrile group. So this one is not the carbon number 1. So we have here 1, 2, 3, 4, and 5. We have 5 carbon atoms, and the parent or the name for alkane with 5 carbon atoms is pentane. Therefore, the name of this compound is pentane nitrile, specifically 1-pentane nitrile. 1 because our nitrile group or our functional group here is located at carbon number 1. Next one is haloalkane. Haloalkanes are used in the production of insecticide. The functional group in haloalkane includes fluorine, chlorine, bromine, or iodine, and its name follows the format halogen prefix, which is either fluoro for fluorine, chloro for chlorine, bromo for bromine, or iodo for iodine, plus alkane. For example, we have here 1-chlorobutane, which means that chlorine is our functional group here, and chlorine is attached to carbon number 1. Here, our parent chain is butane, which means that we have here 4 carbon atoms. So therefore, the name of this compound is 1-chlorobutane. Okay? For the next one, we have here 3-bromooctane. Okay? 3 because our bromine here, bromine, is attached to carbon number 3. And here, we have 2 terminal sides. This is not our carbon number 1 because this side is actually the farthest side from our bromine functional group here. Bromine here is actually nearest to this side than this side. Therefore, this will be our carbon number 1, 2, and 3. And our bromine here is actually attached to carbon number 3 of octane molecule. That's why the name of this compound is 3-bromooctane. Next one is the organic nitrate. Just like the nitriles, organic nitrates are primarily used in the production of chemical explosives like dynamite. The functional group in organic nitrates is NO2, and its name follows the format nitro plus the alkane. For example, we have here 1-nitrobutane, which means that our nitro group here or our NO2 here is attached to carbon number 1 of a butane molecule. This is actually a butane molecule because it has 4 carbon atoms. Therefore, its parent is butane, and our NO2 or nitrate group is attached to carbon number 1 of butane molecule. Now, between these two, which one is our carbon number 1? Obviously, this is our carbon number 1 and this is our carbon number 4. This is our carbon number 1 because this side is nearest to our NO2 or our functional group than this side. Okay. Another example is this one. We have here 1, 2, 3, 4, 5, 6, 7 carbon atoms. Therefore, our parent chain here is heptane. Now, our NO2 here, our NO2 is attached to carbon number 2. Therefore, its name is 2-nitroheptane. Okay, 2 because our NO2 is attached to carbon number 2. This is our carbon number 1, not this one, because this side is actually the nearest terminal side to our nitrate or to our functional group. Okay? This one is actually the farthest side from our nitrate or nitro group. And for the last one, let's have here the ether. Ether is primarily used as an organic solvent. The functional group of ether is an oxygen that is located between 2 chains of carbon. Now here, our 2 letter R's here represent the 2 chains of carbon that are separated by oxygen. The name of ether follows the format alk, oxy, alkane, where alk is actually the prefix for the shortest between these 2 chains of carbon here, and alkane is the name of the longest chain between these 2. Okay? For example, we have here ethoxypropane. As we have noticed here, we have here chains of carbon that are separated by oxygen. Okay? In this one, the first chain consists of only 2 carbon atoms. The second chain, which is actually located here, consists of 1, 2, 3. 3 carbon atoms. Now take note that this one is not carbon atom. This one is not carbon atom. Okay, they are bound to oxygen. Now for this one, of course, the shortest is this, which consists of 2 carbon atoms, and this one is the longest. Now for the longest chain, our longest chain here consists of 1, 2, 3, 3 carbon, and the name for an alkane with 3 carbon is propane. Okay? Now the name for an alkane with 2 carbon should be ethane. However, we are just going, because this one is the shortest among these two, for this one, we are just going to get the prefix for ethane, and that is eth. Okay, that's why we have here eth. And between them is oxygen. That's why we have here oxy. Therefore, the name of this compound is ethoxypropane. Another one is this one. For this one, we have here 2 chains of carbon, this side and this side. For the first chain, we have here 1, 2, 3, 4, 1, 2, 3, 4, 4 carbon atoms. And for the second chain, we have here 1, 2. Okay, and between them is of course oxygen. Okay, now for the first chain, we have here 1, 2, 3, 4, that's butane, right? And for the second chain, 1, 2, that's ethane. Now between these two, which one is shortest? Obviously, the shortest is this one, which only consists of 2 carbon. And therefore, we are not going to name this as ethane, but just eth. So we have here eth plus oxy, and then the longest one is this chain, which consists of 4 carbon atoms. And therefore, the name of this compound is butane, ethoxybutane. Okay, so those are the 7 non-carbonyl functional groups. So thank you for listening and good day.